Originally, and even in many people still, people thought that Alzheimer's disease is the result of these plaques accumulating in the brain. These kind of little proteinaceous, little thick things that are preventing neurons from sending the signals throughout the brain for the brain to think and have normal cognition. We have had drugs that have been available for human use for years that have effectively reduced plaques in the brain and yet did nothing to improve cognition. So that is an immediate challenge of the plaque-based theory of Alzheimer's. When you would look post-mortem or look at tissue donor people who'd passed away, you would look at the brains of people who died with confirmed Alzheimer's disease at the time of death and look at the brain of someone who died without any evidence of any cognitive decline or any compromised thinking whatsoever. And you would be just as likely to find plaques in both brains. So whether the brain had Alzheimer's disease or not, you would still see plaques in the brain. So the whole idea that plaques mattered has long been controversial. About 2 or 3 years ago, they found out that the very first published papers that implicated plaque as a cause of Alzheimer's disease were based on fabricated data. So the scientists who published those first reports that led to the entire theory that Alzheimer's disease is plaque-based were called out as fraudulent. And indeed, all of it was fabricated. And we have spent billions of dollars on studies to try to determine how do plaques cause Alzheimer's disease? Why, when we reduce plaques, it doesn't appear to help the disease? Because the plaques had nothing to do with it. That's just something that some brains have. Some brains have more of these little specks than other brains, and they don't contribute to Alzheimer's disease at all. Now, people with Alzheimer's disease almost always have some detectable instance of insulin resistance, if not full-on type 2 diabetes. To say it more succinctly and accurately, it is simply insulin resistance of the brain. And the brain is a very hungry organ. It is in what I teach is a trinity of high metabolic rate organs. That there are 3 organs in the body whose metabolic rate is so high that it just really sets it apart from everything else. And the brain is one of them. The brain has a very high metabolic rate. So this is a very hungry organ that needs a lot of energy all the time. But the brain is unique in that it primarily will only use 2 fuel sources, and I've mentioned them, namely glucose and ketones. But glucose, in that section of the brain that gets compromised with Alzheimer's disease, the glucose can't just come straight in. It needs someone to open the door for it. And that is insulin, of course, just like we described with the muscle cell, where in order for the glucose to go into the muscle, insulin had to come and knock on the door, if you will. And then the muscle, being a polite, responsive host, would open and allow the glucose to come in. The brain is similar, that in that section of the brain, it has doors that need insulin. It's locked until insulin comes and opens them. So even though glucose levels may be high in the blood, like in type 2 diabetes, you would think, well, the brain can just get all the glucose it wants. And yet it cannot, because it has insulin regulating the entrance of the glucose. And if the brain is insulin resistant, there's not enough glucose coming in. And thus the brain is forced to rely on the only other fuel that it can rely on, namely ketones. But the same person who's eating all the time to keep their blood glucose high all the time has so much insulin in their blood that they're never making enough ketones to fill the gap. You know, and mind the gap. And the brain has an energy gap now. Brain has a certain energy demand that it needs. And if there's a lot of glucose in a healthy insulin-sensitive person, glucose will fill all of that need. But as the brain becomes progressively insulin resistant, it cannot get all of its energy from glucose. And thus there's an energetic gap. And in the absence of ketones, there's nothing to fill that gap. And the brain says, well, I don't have enough energy to keep functioning as well as I did before, so I have to reduce my function, which manifests as a reduction in the ability to think and process. In other words, cognition goes down. That scientists refer to as brain glucose hypometabolism, or a reduction in the amount of glucose the brain is using. There are scientists that measured this. You can actually infuse people with the glucose that you can take pictures of and see how much the brain is taking it in and metabolizing it. In Alzheimer's disease, the brain is not getting as much glucose, so they call that a hypo, or a reduction in metabolism of glucose. And as much as you and I are describing that scenario as relevant for Alzheimer's disease, you can essentially open up the book of neurological disorders and see the same thing. Depression has a brain glucose hypometabolism to it. Migraines have a brain glucose hypometabolism. Epilepsy and Parkinson's disease. So all of these disorders of the brain, of the central nervous system, the one thing they all have in common is the brain isn't getting enough energy from glucose. And another way of saying that is the one thing all of those seemingly unrelated brain problems have in common is that they all have some degree of insulin resistance. But then it's no surprise that they all benefit when ketones can swoop in to save the day. But that only can happen if the person is giving their body a break from the insulin long enough to actually start making ketones